Um, Sorry to introduce kindly, but just to give you a little background about why I'm here and I get to speak with you all today. Basically, I have 15 years experience in preclinical and clinical research. I did my PhD at Northwestern, did my postdoc at Mayo Clinic, and then a second postdoc at Michigan State and was an assistant professor of research there before coming to the foundation a year ago. I'm a scientific lead for PD generation, and I lead a lot of our industry partnerships around PD generation and cross-foundational efforts. So we're going to start way back in 1817. You probably all know this history about Parkinson's disease, but the very first known essay about Parkinson's disease was called An Essay on the Shaking Palsy by James Parkinson in 1817. That's where the name comes from. If you zoom all the way to now into the future, where are we right now? Immunotherapies are coming out, stem cell research, both for drug screening and cell replacement. Clinical trials are back and going. And as we've heard, there's a lot of gene therapy research and trials ongoing, and there's a lot more coming. What we've learned in these 200 years, again, a lot of you are very familiar with this, but just to review, we know that Parkinson's disease is a disease in the brain. In a healthy subject, the substantia nigra, where your dopamine, the cell bodies of your dopamine producing neurons live, are alive and healthy. Parkinson's disease, those cells are damaged and die, and you lose that production of dopamine. Something happened that has been talked about a little bit before, but I'll talk about it a little more. In the 1990s, researchers discovered the importance of alpha-synuclein as a pathogenic molecule in Parkinson's disease, and that there's genetic mutations underlying some Parkinson's disease. So it used to be, just as the previous speakers were saying, Parkinson's was not a hereditary disease. Now we know it's a much more complicated landscape, both with monogenic, so single mutation causing disease, and then risk factors for these common variants. So there's a kind of famous research paper that came out in the 90s, and it ushered in the golden age of genetics research for Parkinson's disease. And this was all built around a mutation that was found in alpha-synuclein, which we've heard a bit about, right? It's a protein. The gene is SNCA, and we don't totally know what alpha-synuclein does, just like when I talked about LRRK2 in a normal situation. We have a lot of it. It's one of the most abundant proteins in our brains. What we do understand is that it plays a role in this vesicular trafficking. So when two neurons talk to each other, they release neurotransmitters in those circles are called vesicles. They release it from one process to the other in the synapse. That's how they talk to each other. And alpha-synuclein is really important for this process. In Parkinson's disease, we see many times an aggregation of alpha-synuclein. When you have lots and lots of aggregation, these can form Lewy bodies. They also, and it's always been a hot topic in the last 10 years or so, that some forms of alpha-synuclein can actually seed other neurons to have their alpha-synuclein start to aggregate. So it's a progressive part of the disease process. And then again, this aggregation and then the effects on things like the mitochondria and the lysosomal function that other people have talked about lead to this damage and death of dopamine producing neurons. So why do we care about a mutation in alpha-synuclein? Why do we care about genetics in Parkinson's disease? As the previous speakers, they set me up so well. They talked about how really until the last 5 to 10 years, there wasn't much push for genetic testing in Parkinson's disease. There's still lots of clinicians that don't feel like there's a real clinical benefit to it because there haven't been direct next clinical care steps, but those are coming. The other thing, and specifically you can think about, is when we start to understand the genetics, the underlying Parkinson's disease more, we start to unlock the potential of precision medicine. So we have talked about this today, but not with using that term exactly. So to just bring us all to the same page about what I mean when I say precision medicine, currently we have this kind of conventional one-size-fits-all therapy. So you have your group of people living with PD, you have a treatment, think levodopa is probably the easiest one to think of. Some people benefit, some people don't, and some people have adverse reactions to it. What we want to see and what genetics help us do, or other biomarkers, is you start to stratify the population of people living with PD. So you have your population, they get genetic testing, you understand um, their genetic code, and then you can tailor the treatments based on what you understand about their genetics, with the hope that those tailored treatments will lead to a benefit for everyone based on their genetic signature or their molecular biomarkers or other outcomes. So besides personal, like if I had a genetic mutation that led me to have Parkinson's disease, and then I can get the proper treatment for me, in addition, understanding genetics could help everyone. And this, the Neuron 23 talked about this a bit, as did the Denali, that if we understand genetics, we might be able to help everyone with Parkinson's. And I'm going to give you an example actually outside of the Parkinson's realm. So in the 1970s, researchers learned about the genetics of cholesterol synthesis, and there was a clinical trial done using statins to treat a rare genetic condition of high cholesterol. And that's what led to statins being produced, and now is one of the most highly prescribed treatments for high cholesterol across the population. So it was a very targeted goal to begin with, but then it could be applied across big populations. And that's what we hope for in PD too, right? That you can help the individuals with particular variants, and by understanding those mechanisms, hopefully you can help a larger population. But to do this, we have to understand population genetics for people living with Parkinson's disease. And so about 5 years ago, the Parkinson's Foundation started our genetic registry called PD Generation. And this study, for those of you who aren't familiar with the foundation, really is in line with three major goals for the foundation. We want to improve care for everyone with Parkinson's, advance research, and empower and educate our community. We do this by providing certified, so clinically certified genetic testing and genetic counseling to people living with Parkinson's disease at no cost to the participant. All people 18 years of age or older with Parkinson's disease can join, and the results are given back to you by a certified genetic counselor. This is very different, very unique. Most trials, if they do genetic screening, many times those results are not returned to you because they're not a clinical study level, they're research level grade, and so you can't give participants back that information. You get your report, you talk to a real person on the phone or via Zoom, you can talk about what it means for you and your family, and then you can talk to your clinician, etc. Our primary panel includes 7 primary Parkinson's genes: LRRK2, GBA, SNCA, Parkin, PINK1, PARK7, and BPS35. This is a snapshot of our current data. This was beginning of August, and you can see actually in our study so far, we have just under 22,000 results that have been collected, and we get just about a 12% positivity rate if you include all 7 of those genes. And then on the right, you can see the genes broken down, the most common by far being GBA, followed by LRRK2 and Parkin. There's a link down here, and I'm not sure if these slides are shared, but you can come see me at the table sometime today or tomorrow. Our results update every month live, and you can interact with the figures on our webpage and see more about state-to-state enrollment, countries, ethnicities, lots of different information you can get if you're interested. In addition to that primary panel of the 7 genes, we have started offering secondary gene panels. So there's a 21 gene panel that is related to Parkinson's or Parkinsonisms. So these are genes where there's less research that supports their connection to Parkinson's, but we still think they're important. There's also genes like one that underlies frontotemporal dementia. So if you had that gene variant, you'd want to know. Another one is a third panel that we offer is called the CDC-10 or the Tier 1 genes. And these are genes where they have interventions that are available for them, and they're hereditary, like breast cancer, and there are some inherited cholesterol diseases, so like the BRCA genes for breast cancer, and others. So you can opt into that information as well. So you can get the primary panel, a secondary PD panel, and the CDC-10 through PD Generation. It's really easy if you haven't participated, and some of you have, and usually the feedback is positive, that it's relatively easy to participate, especially if it's your first time participating in a clinical study. This is a super easy one to do. You can go to our website, you schedule an appointment for a blood draw. You can do it in a clinical site. We have almost 60 in the US. Or I have a tassel kit out on the table as well. It hooks onto your shoulder and it has a little lancet in it, kind of like if you do a blood glucose testing, and sticks on there. You push the red button, collects about 500 microliters of blood. You ship that to our genetic testing partners, and then those results will come back, and then you'll be contacted by a genetic counselor. Here's the tassel kit. There's a red button that you get to push. This has really helped with accessibility across the country, or just the comfort of your own home. You can do it yourself. You can have a loved one help you, a care partner. It's pretty straightforward, and most people think it's less painful than a venous draw. Here's our cumulative enrollment. Since when we started back in September 2019, up until August, beginning of August, here we're at almost 27,000. We're over that now, but we are continuing to grow. We just got a $25 million grant from ASAP to continue this work this year. We are international in the US, Canada, Latin America, and Israel. Our study PI is Roy Alcalay. He is a MD movement disorder specialist that was at Columbia. He's Israeli and now lives in Tel Aviv. I'm going to share with you a quick, like a 4-minute video. This is one of our participants. You get to watch him from start to finish. His name is Rex. He lives in California, and he was tested at UCLA. And so you can see the whole process.
Yeah, Rex.
Hi, so I'm the study coordinator for PDG here at UCLA. Great to meet you. Thank you guys so much for coming today.
Thanks for having
We'll
us.
take a seat. The way that the blood collection is going to work is probably something that you may not have seen before. So it's not through venipuncture. It's a device called the tasso. There's a lancet inside, and then there's an adhesive on the back. So this just sticks onto your arm and it collects blood over the course of 5 minutes. It's pretty painless. A lot of people don't really feel anything at all from it.
Okay.
Okay, so I'm going to have you lift up your sleeve a bit, and then you're going to hold this on your upper arm for just a few minutes. This is to get the blood flowing.
Okay.
It's warm. It's
You can take the heat pack off now. On. And then the button, you might feel a little tickle.
I can barely feel that.
If you're scared of needles, it's a lot better because you don't have to see anything. It's just a
Yeah.
little piece of plastic.
Yeah.
All right, and take this off.
And that didn't hurt either.
All right, we are all done. That's it.
Easy. Thank you so much, Alex.
Yeah, you're welcome.
Nice to meet you.
It's great to meet you.
I want to do my part. I don't want to be a victim. I want to help. I want to use this diagnosis to further research, further cure. I would love to see a cure, and I'll do my part for that.
If you are a caretaker, the ability to do it at home and be able to stick it and it's not too invasive. All of those things make a really big difference.
My name is Priscilla. I'm one of the genetic counselors calling you today from Indiana University.
Hey, Priscilla.
The call today is scheduled as part of your participation in the study with the Parkinson's Foundation. And so the plan for us today is to have a chance to really review your test results. Then we'll talk a little bit about Parkinson's disease. And at the very end of the session, we will review your family history information. Okay?
Sounds great.
So basically, the test was looking for differences across the gene. In your case specifically, you have what is considered to be a negative test result. As you can imagine, this result in itself doesn't change your diagnosis. So everything that you've discussed with your neurologist and recommendations remain the same. And in fact, having negative results is actually really common. We see this in about 87% of cases. What we understand about Parkinson's disease is that it's a pretty complex disease in itself. It's due to a combination of factors. Some of these are genetic, but then we have other factors outside of genetic that can play a role. So things like environmental factors. And I really like this puzzle representation because it tells you all these other things. So things like aging and the environment, exposures to chemicals and pesticides, and again, genetics. So all these different things come together for eventually an individual to develop Parkinson's disease. And what's complicated is that we cannot pinpoint exactly, what is the reason behind an individual's Parkinson's disease. You'll be receiving some information from us. Once you do receive this information, feel free to share with your neurologist. It was a pleasure to meet you both. And again, I do want to thank you for your interest and participation in the study, okay?
Thank
You'll
you.
take care.
Thank you. I received my results of my PD gene test. Turns out I was negative for all 7 gene variants that they tested for, which I thought was surprising because it's in my family a lot on both sides.
It's better than that. I'm here to be supportive, honestly. I feel like this was a journey through your family history, through everything you have.
If this test, my participation in it helps somehow people not get it in the future, then I did the right thing.
Well, thanks for letting me share that with you. It's on our website. Rex is really interesting, as he mentioned. He had a lot of family history of PD and he was really surprised. You can kind of feel his sort of relief, sort of disappointment. So, we understand it's a complicated thing to get these genetic results, whether negative or positive. And so that's why we implement the genetic counselors to be there with you and be able to discuss the specifics. Other reasons why people participate in PD generation, right? Understanding risks to family members, your own personal care management, supporting research that benefits the greater community. All of our data eventually makes it into a global database. De-identified, just the genetics data makes it in there, so researchers can pull from that database and use it for their studies. And then relevant to what we've been talking about a lot today is enrollment in clinical trials. So if you understand your genetic background, you may know what trials you might be eligible for. And in that vein, just recently, about 2 or 3 weeks ago, we had a press release where we are launching a new program. It's called PD Trial Navigator. And it's going to help match people to clinical trials that they're potentially eligible for. Our goals are to provide education for the community. We want to build a diverse trial-ready cohort of PD generation patients that are ready for the next step. We want to accelerate therapeutic development. We want to reduce those barriers that make it difficult for people to enter into clinical trial and provide personalized navigation through the process. And we want to enable precision medicine for genetic PD. So we're going to connect the right people to the right trials at the right time. We all know, and our friends earlier today talked about this, clinical trials for PD are notoriously difficult to enroll. And then when you really focus down into these genetic targets, it becomes even more difficult. There's just not that many people who are eligible. So how do these companies find these people? And then you have to be eligible, you have to want to do it, you have to travel or not. It becomes very complicated. Something really interesting that's come out of PD generation, when we surveyed participants, about 4,000 of our participants responded to a survey last summer. Almost 80% said they were interested in being recontacted about future research opportunities in clinical trials. PD generation sort of serves as a gateway kind of to this world of clinical trials. It's a registry, it's low stakes, low risk. But people, whether they're negative or positive, many say, okay, now what next? What can I do next in this journey? So this is what the program would look like for a participant. We would identify participants from our PD generation database. Again, that has over 27,000 enrollees currently. And we're going to start with genetic mutations of interest, so like LRRK2 and GBA, for instance. We will reach out to them initially, provide any clinical trial education, general education, feel out how comfortable they are with clinical trials, precision medicine, disease-modifying therapies, all those things we hear about but might not totally understand. Then they would consent into PD Trial Navigator if they wanted to. We do a screening survey to determine eligibility. So like, what medications are you on? Where do you live? Are you willing to travel? How old are you? Just getting all that information back to be able to share with the clinical site if it goes that direction. And then we would have another touch base, so whether it's phone, email, Zoom, our navigators who are trained in both clinical trials and community engagement would likely have a phone call with these individuals and talk through the specifics of the trial. So let's say you are LRRK2 driven, you're eligible for the NULAC trial, they would sit with the person and talk them through the process. There's more than one LRRK2 driven targeted trial. We talk through all those trials that you may be eligible for. We want to give the information out about everything that's available and that's appropriate for that individual. If they want to continue, they would consent into sharing their contact information with the clinical sites, and they would get the clinical site information as well. And then we'd ask them for some feedback because we're going to grow this program, hopefully expand, and we want to make sure we can reiterate it and improve as we go over the next few years. We're really looking to bridge the gap from knowing your genetic status and enrolling in a clinical trial if you're eligible and interested. So thank you so much, and I'll take any questions.
I have a question that you may or may not be able to answer, but if we switch gears a little bit to privacy related issues, I know there's some benefits from the Federal Act, but there's also some limitations both to the GINA and HIPAA. Can you speak to that a little?
Sure, a little bit. We are very, very careful about PHI and HIPAA. We don't share any PHI. It's in clinically, it's a database called REDCap, secure, it sits with the foundation. And so none of that information really leaves our hands unless there's a consent or further interactions with that participant that make it appropriate. So we always follow the appropriate steps. When you enter PD generation, you do consent to recontact. So about the study. So we send quarterly emails to our PD generation participants, and that basically because it's study information updates, and so we can send you an email. So that's kind of the extent of that back and forth. When the genetic data leaves the foundation, it's all de-identified for research purposes. So all that PHI is stripped. They can no longer, it's like double coded. So if I try to go backwards, I have to go through multiple keys backwards so that it can't get reconnected to the individual. Obviously, there's always a risk of being hacked and those sorts of things. And that's something that we can't say for 100% is never, ever, ever going to happen. But we do everything we can possibly do to keep the information secure and keep that PHI locked up. And we hope as a trusted partner in the community that people, trust us to have their best interests at heart and take care of that information. We hold it very dearly and near to our hearts. The act that you were speaking of, right, it makes it so companies or insurance are not allowed to be biased based on your genetic status, but there are some loopholes in the language. So it's not this overarching protection, but it does specify some specific situations where there's protections, but I don't know all the legal specifications of that act.
Okay.
Is that helpful?
It is helpful. My understanding, which is also limited, is that the genetic information, there's a federal act, Genetic Information Non-Discrimination Act, which, and I worry about it not for myself, but for my children. And if I go down the route of genetic testing, that federal act protects not just me, but my children from use of that data for health insurance and employment diseases, but perhaps not for, I think, like life insurance and disability and others. So I'm at the early stages of exploring where those boundaries are, and I'm just looking for some. So thank you.
Yeah, well, thanks. That was much better description than I gave about the federal act, so I appreciate that. But yes, there are limitations, and I think, you know, there's always some catching up that has to happen, right, between the laws and protections and the technology, and so we're kind of playing that game. Other questions?
So you had that 80% that were negative, something like that, and like this fellow that was in the video, and that was a pretty short and simple conversation he had. Is that pretty common? That's kind of the way it goes.
That is definitely edited down. Our average
Okay.
conversation is about 20 minutes, usually a little longer for positive
Okay,
cases.
well, my question is, so if it's negative like that, like most people are gonna be, 80% are gonna be, is the data that you have on that person still interesting to the database? And if you were going through that trial finder, would that still be relevant? Or is that trial finder only applicable if you're in that 20% who have some sort of genetic thing going on? And then kind of a plus question is there any information that you get out of this genetic testing that maybe you don't want to know that's unrelated to Parkinson's, like Alzheimer's or stuff like that? And do you, I mean, I guess people would want to know or not want to know, you know, depending on the person. Is that something that comes up?
Okay, I'll start with your first one.
Yeah.
If the results are negative, is that still relevant on like a research stage? Absolutely, because we need to compare. We need huge numbers of people to compare their genetics to understand what variants are associated with Parkinson's and which part. You need lots and lots and lots of people to be confident in those results, and you need the negatives as well. So it's always beneficial. And on a personal level, there are some therapies that aren't recommended for certain genetic backgrounds. So DBS is usually not recommended if you have a GBA variant. There's some research suggesting that it's not beneficial as it is for other people. Your second question, I'm forgetting. I remember the third one. I'll do the third one. Maybe I don't remember.
Trial finder.
Trial finder. So right now we're in the pilot phase for the PD Trial Navigator. We're starting with genetic studies because it's a more targeted focus, and we're building. And we want to make sure that we can do it really well, and that we have the infrastructure and people and operations and money that we need to do this. We want to see it continue to expand past genetic studies, but that's our initial focus because it's supported by PD generation, and we need to start small and do it well first.
Yeah.
And then you have
And
more.
then, yeah, and the other thing is there's more information than you really want.
So you can, if you do the primary panel, you just get those 7 genes, so 7 primary genes, variants in those genes, that's all the information you get. You go through that first. Then you can be asked if you want the secondary panel of Parkinsonism related genes, and that would have some genes that may be associated with other neurodegenerative diseases like frontotemporal dementia or Wilson's disease. You have to consent into that. So if you don't want to know it, don't consent into
But
it.
it's not like putting your name into 23andMe
No.
or something like that.
No.
That's kind of where I was going.
Yeah, and it's not like an entire genetic report.
Okay.
It's a curated, you know, it's not like here's a file of, you can have it if you want it, we'll give you a jump drive with your entire genome on it. But it's a curated to those 7 genes. Nothing else is going to come out of it if you didn't consent and want to hear that information.
think the trial finder's cool because, or whatever you call it.
That's fine.
If you've ever been at clinicaltrials.gov, it's
Oh, wow.
really a mess to try to find the trial. You know, it's like a 1990s database interface, and but something really nice like that would be ideal.
Yeah, and we're really excited about it. It was one of the initial goals for PD generation, is that eventually we could get there, we could connect between the genetic results and the clinical trials, really to help accelerate this process. But yeah, other avenues, most are either AI or computer learning based, or just databases like clinicaltrials.gov. Yeah, this will be a real person talking to you and knowing your needs, knowing how much you need to be talked to, helping you through the process and your caregivers. So we have high hopes.
Hey, can I ask a question?
Yes.
So essentially, if your results say that you have a genetic mutation in one of the genes, does the trial finder then do the clinical trials that you're then eligible for? Would they need you to do genetic testing again? Can they trust your data as it stands, or do they do like a deeper, let's say, deep dive into that one particular gene of their interest?
That's a really good question. I think it depends on the trial. So ours is a clinically certified test, so it's at the highest standard that it can be at. So it's called CLIA certified. So they could use it. I think most trials are going to rescreen just to do it in their hands as well, and double, triple check that, you know, they have the ducks in a row. So thank you so much.